and then when they come back to there, what's the mapping? I came in 1990, a couple years after I got my PhD from the Courant Institute of Mathematics at NYU. And after that, I spent a year as a postdoc in Zurich, Switzerland at the ETH, and then 3 years as an instructor at Princeton University. And that was a very heavily research-oriented background, although I'd always been interested in teaching. And as I interviewed for jobs at different universities, I realized that at many of the universities, they would tolerate my interest in teaching, but they wouldn't be particularly excited or supportive about it. While at Bryn Mawr, I felt the other faculty in the administration would be very pleased to support my efforts in doing innovative teaching. This is something called the standard map. We're fortunate to have the facilities like these computer labs that would allow me to do creative teaching. And it's worked out wonderfully since I've come here. I've done cooperative learning in my teaching, in which students work in groups. There's a lot of research showing that students learn better in that type of format where they get to talk with one another about what they're learning. I've also developed computer labs for my calculus courses and my course on chaos theory. And that's the basic idea of chaos theory. And more recently, I've gotten involved in a large-scale education project called the Math-Science Partnership. And this is a project to bring college faculty together with pre-college teachers to try and improve math and science education. I had another summer project that I did with a computer science professor here, where our students, a team of 4, made a website using the program Java that would let the user learn about chaos theory by playing billiards, which is my area of research. The idea is in different shaped billiard regions or different table shapes, the ball might bounce in a chaotic way or in a regular way. So another one of my interests is combining these new discoveries in research that I do together with making it accessible to people, the general public, to help show the excitement and beauty of mathematics. In our graduate program, I've supervised several master's theses as well as a PhD thesis where students then do their own original research in this area of chaos theory. In courses, very often we're learning mathematics that was discovered or invented 200 or 300 years ago. And this chaos course shows that there are new areas of mathematics being discovered right now that are very interesting and beautiful. I'm more a pure mathematician, and I enjoy figuring out these kind of abstract problems, but then the applied mathematician or the scientist could take what I've figured out about what causes chaos and apply it to the weather, for example. All of our research faculty could be doing research at a top-level research institution, but have chosen to be here in a smaller, more intimate setting where they get to work more closely with students. So I think we offer a good combination of high-quality research opportunities for graduate students, but also the individual attention that tends to be missing at larger places.